The scoring system is used to keep track of how reliable entities are. Entities that perform well will have a higher score, while those that don't will have a lower score. The scoring system is important because it allows to determine which roles in the system entities should be able to perform. For example, only entities with a score above a threshold would have the right to act as a generator. If roles are like jobs, scores of entities would be their resume, explaining which skills they have and if they have the required capabilities to perform a given job. Some implementations of proof of justice may choose to have a more granular resume by having multiple scores per entity. For example, having role-based level and experience scores, where the experience would determine how close an entity is to being able to level up. In this case, the higher the level, the more likely a given entity would be to perform the concerned role well in the future. Each entity should also have a global reliability score, indicating how reliable they are overall. Scores of entities are determined by sets of rules, which uses their actions as a determining factor. For example, if an entity acting as a generator generates a block that ends up being confirmed and applied, its global reliability score and its generator experience would increase. On the other hand, if an entity is showing malicious behavior, such as always referring to specific entities to validate its blocks when acting as a generator, its generator score and its global reliability score would be negatively impacted. Proof of justice is not limited to a single set of rules. There can be multiple different ones with different uses and purposes. For example, there could be a different set of rules for each role. The scoring system can also be used to grant entities access to different resources or features of the system based on several criteria. For example, an entity with a great global reliability score might be able to access a super-fast networking algorithm that less reliable entities may not have access to. Several implementations of proof of justice will use an entity reporting mechanism, allowing a first reliable entity to report a second entity if it thinks and can demonstrate that the second entity is acting maliciously and found a way to evade one or more rules. The report would then be evaluated by the system and, if confirmed, negatively impact one or more of the second entity's scores and reward the first entity. On the other hand, if the first entity was itself malicious and attempted to harm the second entity's reputation for no just and valid reason, the first entity would then be punished instead of the second entity. Several more parameters can be implemented and adjusted for such a reporting system, such as increasing the punishment if the first entity ends up being considered malicious based on its global reliability score, increasing the punishment of the second entity if it has a history of acting maliciously, and much more. Rules in proof of justice can be of several types. Each type has its characteristics and is used in different scenarios for different reasons, based on needs. Some rules can be associated with more than one type. Regular rules are the most common rules and are used to determine if and how an entity's score should be adjusted based on one or more actions triggered by a hook. For example, a regular rule could listen to a block-generated hook and increase the entity's generator experience by 1 when triggered. Non-deterministic rules are like superheroes. They take justice into their own hands when a malicious entity successfully evades the standard rules. Non-deterministic rules are advanced probabilistic algorithms that take into account a lot of factors before deciding if an entity is guilty of being malicious. They essentially act as a safety net when it comes to spotting malicious entities. Requirement rules prevent entities from doing things or accessing features or aspects of the system if they don't meet certain criteria. For example, entities might have to complete challenges to prove their eligibility. A great example of a requirement rule which would greatly improve a proof of justice-based system would be to require entities to complete and execute a set of instructions in order to gain access to one or more aspects of the system. The set of instructions would need to be pre-approved and predetermined by a portion of reliable entities in the network before being provided to the given entity. The user behind the entity would then execute and complete the instructions and provide results back to the network. If successful, the desired access would thereby be granted. The inner mechanism of this example is quite complex, and more details can be found in the white paper. Score-dependent rules can be of any other type, but are only enabled when the score of a given entity is above a certain threshold. This allows for different conditions to be put in place depending on one or more scores of entities. For example, a score-dependent rule could reduce the score of an entity for every determined number of times said entity acts as an enforcer, forcing a rotation of entities and preventing problems such as stagnation in the system. Adaptive rules can be of any other type and can adapt themselves, such as their impact on entity scores, automatically based on one or more events in the system. Action-dependent rules are like score-dependent rules, but instead of relying on the score, they rely on specific actions. For example, an action-dependent rule could be, if X is trying to do Y, then Z must happen first. Long-term memory rules help keep the system running smoothly by adjusting entity scores according to their long-term behavior. This can, for example, ensure that entities that have been malicious in the past are watched more closely. This can also mean that long-term reliable entities are rewarded more for good behavior or punished less for occasional mistakes. Short-term memory rules are similar to long-term memory rules, but they use a smaller set of data. They only look at the things that happened recently when making decisions. They are therefore often used to identify anomalous short-term patterns. Chained rules listen to the output of other rules, and if an event happens, they will adjust one or more scores of one or more entities. They are often used to give entities a score penalty or reduce the penalty if the entities have been previously flagged as malicious by other rules. Cross-set rules are a way to adjust scores of entities based on rules in different sets. These rules are particularly useful when there is a need to maintain two or more independent sets of rules, but still need to be able to share data between them. Challenge-based rules require one or more entities to complete one or more challenges in order to perform a given action or to access specific aspects or features of the system. The adjusted score of said one or more entities can then be adjusted based on the result of the one or more challenges. This type of rule can be used to implement various policies, such as rate limiting and pattern breaking. Multiple challenge-based rules can be chained together to create more complex policies. Inaction rules are used to calculate the adjusted score of one or more entities if certain hooks are not triggered. They can therefore be used to incentivize entities to stay active in a network. The applying of rules to adjust scores is super intuitive. Once a given entity receives and adds a new block to its local blockchain version, it will execute the rules of all sets in a determined order. This order can be determined using several criteria, such as proof of justice parameters and the hook's execution order. In most proof of justice implementations, sets and rules also have a number that classifies the order in which they should be executed. Several ordering methods can be implemented, as long as rules are executed in an order which can be reproduced by other entities at any point in time. Not only are rules super flexible and versatile because of the hook system and all the different types of rules that can be implemented, but they can also be added, updated, and removed from the system dynamically in a decentralized manner using a voting mechanism made possible by several other aspects of proof of justice, such as feeless transactions, which will be elaborated upon in other videos. In most implementations, when a given reliable entity wants to add a new rule to the system, it can create a poll. Other entities with a score above the first threshold can vote on whether or not they like the idea of adding the new rule. If the poll reaches the necessary quorum, the development of said rule begins. Once the rule has been developed and is ready to be integrated by the system, a second poll containing the code of the rule is created, allowing entities part of the specialized code reviewer role to validate said code and submit if they agree to integrate the rule as it is programmed. Then, if the second poll reaches the necessary quorum, the rule is added to the system. Adding a new rule in this manner allows for a decentralized and democratic way of governing the system, while still allowing for a certain degree of flexibility and ensuring that votes are made by legitimate entities. Rules can also be updated and removed using similar, slightly adapted processes. BB Inventions, high-tech research for curious minds.